Welcome to
KidMath159.
KidMath159. So we worked, this is one where we're not going to solve this problem all the way through because this is what we worked on for the whole morning. This is a problem from an old Mathcounts test. And it actually asked to find the first three positive solutions, but we're going to find all of them. Find the positive solutions to x minus floor of x equals 1 over floor of x. Okay?
Yeah.
Alright, so how do you want to proceed with this?
Well,
what are we talking
we
about?
can break it apart and graph them.
Okay. Even before that, though.
Well, we could see that nothing below 1 is going to work here.
Okay.
Because the floor of something below 1, that isn't 0, is 0.
Nothing below 1. So we're looking for positive solutions. But it turns out nothing below 1 is going to be true because what's the problem below 1?
The problem below 1 is you get 1 over 0.
You get 1 over 0. So anytime we have any fractions hanging around, we got to make sure those fractions aren't 0. Okay, so our solutions to this are not going to be less than 1. The x value is not going to be less than 1.
Yeah.
Okay. What else can we say about this equation?
Well, no integers are going to work.
No integers are going to work. That's an interesting. And why is that?
Because you're going to get 0 on this side.
Okay. And how do we know we can never have this side equal to 0?
Because if this is an integer that isn't below 1, we're going to get a positive number.
Okay. This is going to be positive at integers.
Yes.
At bigger than 1. Okay. So it's very interesting. It's very similar, by the way, to quadratics. Remember, with quadratics, one thing we were really interested in finding out about were the zeros. That's what you found here, integers. And then backing up, we didn't have problems with fractions with quadratics. But here we have also zeros on the bottom, which we got to worry about. So nothing below 1 and no integers. Okay. And the next step was to sketch a quick graph of this, which was pretty interesting, actually. This was always 0 at integers. So this is just x minus floor of x. And it went up to 1, but it didn't ever hit 1. I'm sorry, I'm not drawing it very well. Okay. And how could we see that x minus the floor of x never gets to 1
because
as the y value?
When it's 1, it's back down to 0. Because you hit an integer.
Okay. In between 2 integers, all this is measuring is the non-integer part, right? Like at 1.75, I get 1.75 minus 1. Or at 10.32, I get 10.32 minus 10. It's measuring the non-integer part, or what I want to call the fractional part, but even for real numbers, like pi, I would get what's after the decimal.
Yeah.
Right, so I get this interesting little function that's supposed to be symmetric. It's supposed to be the same everywhere, but at 6:30 in the morning I can't draw it quite the same. Now what about this one? What about 1 over floor of x?
Well, this one, for integers, it's going to be 1 over whatever integer that is.
Okay. So at 1, I get 1. At 2...
2, it's a half.
At 2, it's a half. At 3...
It's a third.
It's a third. At 4...
It's a fourth.
Maybe I better stop there. Okay.
And then it just goes, it's going to go out to where this point begins.
Okay. It just keeps going straight across because the values are the same for greatest integer, or for floor, in between the integers. So from 1 to 2, sorry, again, my graph isn't super awesome. But, okay. And all of a sudden we see the intersection points of these two graphs, and this is where they're equal. What is this point here? It's between 2 and 3.
It's 2.5.
It's 2.5. This is a half, and this is going to be 2.5. That's what we talked about here. I get the non-integer part, 2.5. What's this one here? What's this intersection?
It's going to be 3 and a third. And then 4 and a fourth.
4 and a fourth.
And it's going to be 5 1/5.
5 1/5.
It's going to go on forever.
Okay, in between n and n plus 1, what is my intersection point going to be?
It's going to be n plus 1 over n.
Plus 1 over n. Hope that shows up on camera. This marker's a little light. So it's interesting. So we just found all the intersection points. All of them. The math conference probably asks you to find the first 3 and then add them up. I'm not going to ask you to add up all of those. Add up to a big number, right?
Yeah.
Yeah. But that's pretty cool. And I like the problem solving, breaking it into pieces. Okay. Some basic facts. What does this look like? What does this side look like? Boom, 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 boom. Interesting function. What does this side look like? This interesting function that seems to be getting smaller as you go out, but almost like walking down an infinite staircase. And then we can see the intersection points. Anyway, very cool problem. Very cool problem. That's from an old Mathcounts, which is an exam where you got to go fast, fast, fast. It's a little hard to see how you do this fast, though, right?
Yeah.
Boom, 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 boom. Maybe you just set your brain on like 100.
Maybe.
Anyway, good job this morning. That was a neat problem.